So how, I guess with the exception of Chris, who's brand new, how was this morning? How did it go? Good? Okay. So for this afternoon, we have one more exercise, which is not dealing with what we all care about, which is processes and distributed stuff. And then we're going to get into processes. And then your mind will expand or break or something. But don't worry. Yes, that's a nicer way of putting it. You will reach Satori. How was lunch? Good. Did anybody eat a little bit too much and is worried about a food coma? Because
It doesn't matter how much you eat, there's always food coma.
to some extent, yeah, the digestive system takes, priority. All right, so the next exercise, that is not where the focus is, hello computer, is rock, paper, scissors. It's going to be 2 steps. I'm going to show you the 2 steps now because it might help you decide what you're going to build. Hi. Oh no, you can't come in. Restart it. Get out. So step 1, you've probably all played this at least once when you were a kid. It's a wild guess. You might not have played this version. But that's it. Right now, this is the time for you guys to kind of work on this, build those 2 things. Oh, by the way, if you are just joining us and you weren't here this morning, there is a channel on the functional programming Slack called intro-to-elixir, in which there are some code samples and a link to the slides. And I can paste that in here again. Because I don't want you to be bound to the slides that I'm showing here.
Sorry, what's the channel code again?
Intro-to-elixir. It's all right. Welcome back. So the time that I allocated for this was approximately 25 minutes. So don't feel rushed. Take your time. Talk to each other. Ask me questions. Structs? No, not yet. We're not getting into them today. Like we,
Because the module and the
yeah, just it's additional code and cognitive overhead that we don't need yet.
Are you going to use it as like EXS scripts or as like test.
So this is literally however you want to build it, as long as the code ends up working. Two of my friends chewed me out during lunch for not doing test-driven or test-guided. And I said that after I put together the base material, I had over 5 hours of work already before adding time for questions. So I had to cut something. And then they gave me, crap for cutting tests.
I'm not sure yet. I haven't gotten there.
Can you enforce ordering on atoms?
Enforce ordering?
Yeah, like will they go out and string like alphabetical order or
Like if
compare for one greater than the other?
Oh, I don't know. I've never tried. I've also never built rock paper scissors that way before.
Trying to not have to do each possible pair.
I usually just do a map, right? Like this is your input, this is what it wins over.
Sure. You can have a map with like a tuple scheme.
My basic implementation tends to be the key is the one player, the player you're going to judge against, and then the values are either what you win against or what you lose against.
Sure. Yeah.
So if the other player matches the value of that, then you're good or something like that.
Sure. Yeah, I'm just trying to. I would like to only have to do it one direction instead of
Right.
both ways.
I mean, that should work. Like if rock goes to paper, then you know that if the other player is paper, then they win, right? You lose.
Yeah.
So.
Sure. Yeah.
What?
I had a lot of coffee earlier, so I'm just gonna giggle randomly.
All right, that's fine. I have a friend who landed from he came home from the UK like two days ago and landed yesterday here at 10 p.m. or something like that. And then his flight was actually 3 hours late, so he landed he got to sleep way past midnight local time. So he had 6 cups of coffee this morning.
Is there a data structure in Elixir that it's easy to get the index of? If I say give me the index of this value.
I mean, lists will do that.
Okay, because I'm looking through documentation and not seeing it. Maybe I'm looking for the wrong word.
Maybe I'm lying to you. I mean, I've done it before. Give me a second.
Uh-huh.
I'm clearly lying to you.
Okay.
I think, yeah. This might be one of those things where you have to fall back to Erlang and get like index list or something like that. Remember, if you're done and this is too easy, there's another one to implement. And if that's still too easy, first of all, the intent is to add as many rule sets as we want. So if you want, implement someone being able to define their own rule set with arbitrary words. And after this, we're getting into processes finally. So. Oh no, enum.findIndex. Yeah, okay.
It does?
Yeah, findIndex is a function on enum.
Ah, I was looking at the data structures themselves.
Yeah, the data structures have, really not much behavior defined on them because they're just data structures. They're basically inert.
Right, okay.
Okay.
I think I have this first one.
All right, hopefully you'll be back for the processes and
Yeah,
OTP.
I like to be.
Okay. Who's Byron? If you're bored, then go look up macros and set up a macro to deduplicate all that stuff. Well, I mean, you have the one function defined 1,000 times. It is very short. I can't deny that. Also, does that work? Your code, it seems like you have a draw and everything's going to be a draw all the time.
No, it's the winner should only catch if they're the same thing.
Oh. Yeah, I guess it would. I will probably suggest you make describe result a more public function, because we're going to use this code for when it's inside a process, and so doing io.puts will not necessarily be the best way to return the information. So it's been about 15 minutes. How are we doing? Yay! Okay.
You make Wizard Spot with your hands.
I've forgotten, but if you want, there's a Wikipedia page that shows it. I'm pretty sure Spock is just that, because that's
Right,
Spock.
that makes sense.
I don't. Maybe I think it's something like this, or dog or whatever. Yeah, there you go. That's it. That. Asking the important questions.
I think
I'm wondering if there's a way to have giant combination of. I'm probably missing something, but I don't see how we can avoid having this, like, all the combination of.
So the way he asked the question before, the way I implement it normally is with a map that holds the rule set, and one player's move is the key of the map, and then the value is going to be a list that holds all of the possible choices, which might be either a loss or a win, depending on how you implement it.
It's a matrix.
Yeah, essentially.
So you have a map.
It's, oh god, it's something like this. We put this in the chat room. This is not an editor. I hate everything. Ah. It's not Emacs. It's definitely not Emacs. Something like this. So you can check if player 2 is a move inside the value of player 1.
example of rules, can you put that directly in the module? Does it need that?
What I wrote there,
Yeah. Or in the beginning you had like a
the @ sign.
module constant.
Yeah. You can put that in with an @ sign if you want. That will be a rule that's hard coded into the module. So if you want to write your code that way, like if you're okay with that, then yeah. Right. There's so many ways to solve this problem. I'm not going to tell you one way is right or wrong. And we're not going to do anything so complex with it that one implementation will obviously be a problem for you in the next 4 hours. At least as far as I know. I mean, you know. This is all your minds against my mind, so I'm going to lose. Will anyone be terribly sad if I mention that we're at the 25-minute mark, so it's time for a 5-minute break?
Yes, terribly sad. Terribly sad.
Well, then I guess I won't mention it. Well, I'm going to go to this slide anyway. If you want to take a break, you can. You don't have to. You're grown people. At least that's the assumption. How are we doing solution-wise? Something that works, mostly-ish? So we have 2 solutions in the channel. Does anybody else want to share theirs? We might ooh and ah over it. It's only polite after all. If not, no worry, we'll just move on. Did everybody have a good 5-minute break? Okay, let's finally get to the entire reason people are excited about Elixir. Let's talk about processes. So these are not Unix processes, which is part of what makes it cool. There's another significant number of reasons why they're cool has to do with how Erlang and the Erlang virtual machine are implemented, and we're not getting into that. But Sasha Jurek at MPEX this past Saturday did a really good talk on this, so that will be online if you're curious. I have a coworker who said this, and I thought it was really insightful, so I modified the talk to add that in. If you look at things like Ruby or JavaScript, right? This or self, what they refer to tells you what the language cares about, right? The unit of thought in the language is what you can sort of self-reference. So in Elixir, self is the current process. Like if you go to the REPL, if you go to IEX and you type self, it's going to return a PID object, the process ID for the process that is the REPL. And before I go further, how much of what I just said makes sense? All right, 1. Is that 1 out of 5 or is that a thumbs up? This much? Cool.
This much.
All right. This much is acceptable. We're in range. Yeah, you're right on time.
Yeah. The REPL gives you a nice error message if you don't use parentheses.
Is it an error message or a warning?
It's a warning.
Yeah.
It's very friendly.
They're deprecating that. It used to be that you could just call the function, any function without parens, and they decided that it would make the Elixir behave more strangely, so they are deprecating that, and I'm not sure when it will be actually removed, but then you'll get an error.
Is that for all function invocations? Can you do like function name, number 1, right?
It's all function invocations need parens. Well, so specifically function invocations that don't have arguments need them because
that's the
because it's hard to make the distinction between a variable with the same name. So because we're talking about processes, then we have to figure out how they can communicate, and that's when we talk about messages. There's 2 things you can do with messages: send them and receive them. If this sounds patronizing, I don't intend it to be. I really don't. This is just like, these are the building blocks. Right. These are slides I added like 3 days ago, and so I haven't gone over them with 12 people, so I don't know by heart what they are. But someone asked this question, and if you send messages to a process, in which order are they received, and in which order are they processed? And those are good questions. They're received first, and they're dealt with first in, first out. So the first one to get there is the first one that'll be dealt with. But the receiving process gets to choose and pattern match for the messages it wants to handle first. Essentially, when you send a message to a process, it gets into the process's mailbox, and then you have to call receive to say, okay, I want to receive a message that looks like this, or just receive any message and do something with it.
So any message in this mailbox that matches this pattern will be taken out immediately.
But yeah, as soon as receive is called, it will pull the first matching message.
All the messages with that could be received but are not currently.
If you're trying to match for a message that doesn't exist, that is not in the mailbox, your process will block waiting for that message. So if you create a receive block and you don't want your process to just block, you might want to, that's a weird sentence. If you create a receive statement, and I'm going to show that soon, and you don't want your process to block, you need to define some kind of default message receptions to handle so that you can then move on with your system, or with your process at least. This is about the simplest thing I could come up with. So the way it works is you send to the PID a message, right? In this situation, I chose just the atom hello to showcase the amount of imagination I have. And you see that this returns hello to the REPL. So that's the return value of that function call, or that evaluation. It's hello. On the next line, I start a block for receive, and I only put one thing in that block, and that's to match on a message that is hello. And then when it receives that, I want it to print out world. And then I mark end. So what happens here is the second I press enter on this line, the REPL goes into a loop of waiting for a message that matches hello. Because there already is one in the mailbox, we don't wait any time at all. It just finds it, and then it processes it. And it knows that when it receives that message, it should return world, so that's what it does. Mind's beginning to bend?
Yeah, where is the mailbox is the Elixir runtime, essentially, and then send fires up processes, or these are not Unix processes? They're
not. I wish I had a diagram for this. I have chalk, but I'm not sure that'll be very helpful. So every process has a mailbox. That is how it's built, right? You don't see the mailbox, but it's there, right? The Erlang virtual machine takes care of that for you.
And you're throwing hello into this, like into the ether, and one of the receive hello mailbox sees that somebody has sent this message that matches its reception.
So one thing that's a little abstract here and not obvious is that when I call send, right, I am calling send from the process of the REPL.
Oh, I see. Okay.
And I am sending it to the process that is the REPL, which is self,
and then
right?
By calling receive within the REPL, it's like that. You don't have to do receive self.
Right, because receive only works in the current process.
Could you give an example of how this would be useful, like in a real-life application? Like where does Elixir fit well? Like what style?
So soon, very soon, we're going to get into the distributed map, so you'll see that, and that'll be cool. It's hard to get value out of just that because it's the REPL and it's like one process, but yes, and so is Snapchat, I think.
Right, a chat app.
Yeah, and so is like Riot's messaging system, a chat system, and Discord is written in Erlang.
Can these talk seamlessly with Erlang actors? I assume that this is just Erlang. It's essentially the same thing as Erlang actors, right?
Yes.
Okay.
Yeah. I wrote code. All right, I'm going to take you guys through this because this is the first part where your mind might actually just break. And we have to pick up the pieces because there's more stuff to come after that. So at the top, I take the return value of the function self, which we know is the PID of the REPL because, as you can see, I'm in the REPL, right? and that is 0.80.0, right? And PID is process identifier, and that's literally the only purpose of this thing. On line 9, I define a function that I call velociraptors. Don't ask me why I did that. It's a function that's going to send to the PID of the REPL, right? Whatever the current process's PID is, and that's current when the function is run, and then the string velociraptors inside a tuple. Are you okay with me so far? Leap of faith good enough? Okay. Then I call a function called spawn, and the documentation for that function is up there, right? This will create a new process, and the only responsibility this process will have is to do whatever is in this function. So that means the Erlang virtual machine will create a new Erlang process, give it the only task of doing whatever this function is, and then the process will exit. Yeah?
So once it's done sending this message, it's going to die?
Yes. The return value of spawn is the PID of that new process. How's that so far? Cool. So what this actually does, right, is it's going to send to 080 the value 0980 and the string velociraptors. Yes, good, bad, horrible, cool.
Better than foo.
Better than what?
Better than foo or bar.
Good, all right.
Dinosaurs are much more interesting.
I'll remember that for next time. And then I define a block for receiving messages in the REPL, which makes sense because a message we know for a fact went to it, right? And I want that message to be the tuple that matches the child PID and some random message. I assign this to a variable. And then I print out the message. And this prints out velociraptors. And then it tells me OK because it did its thing. Why do I need the caret here? That's because this tuple is on the left side. And so it would otherwise assign a value to child PID. So I have to tell Elixir that I really want to match on the value of this variable and not assign a value to this variable.
Is receive blocking in this context?
Yes, it will block for...
Until it perceives.
Yeah, I mean, it's going to block for a time that we as humans can't perceive, because by the time we run this, this will already be done.
Right, so I guess I'm going to, like, you couldn't write the receive above and then send the message.
That's correct. Because this is the REPL, if I had written the receive above, this would be waiting for a message.
Right, okay. But yeah, it's fun.
Yeah.
Stay there.
If you did receive multiple times, like once it's received once, is it?
It's done. It's done receiving messages. So if we sent 12 messages, then with this we would only receive one that matches this. Just one.
What's the syntax for this line? For the array?
For this line?
Have we seen it before?
The caret is an operator, which we talked about in the matching slide.
Yeah. So this arrow, right? This is actually, I guess it is a new bit of syntax. What it's saying is when you receive a message that matches this, then run this code.
But you can normally you can assign variables inside of that pattern. So a message is a variable, right?
Yes, message is a variable.
Because we put the pin in front of child PID, it's taking the value of the child PID variable above.
Oh, yeah, I understand.
Yeah. Right, this is new. This syntax, by the way, is the same syntax you would see for a case statement or a conditional statement. Sorry?
No, I want to say it's for a con.
Yeah. Right.
You're listening.
Thank you.
So if you didn't put the caret,
Yeah.
child PID, it would call spawn velociraptor.
No, so it's hard to make this much like code with complexity fit in a single slide, but I'm counting on all those questions to come out, so thank you. If you didn't have the caret here, what would happen is it would match on absolutely any message that has the structure of a tuple with two elements.
Oh, okay. So when it's just like in rock, paper, scissors, a lot of people do like, you know, X, Y.
Yeah,
whatever, and
right.
Just assign whatever comes in to those.
Right.
It's placeholder.
Yeah. Like if I remove the caret here, and I put the string velociraptors exclamation mark here,
Yeah.
this would only match on the message where the second element of the tuple is that string.
Does this do syntax with the arrow? Does that appear anywhere, or is that just what we see?
This is something we haven't seen a lot, but you will see the same syntax for case statements and conditional statements.
But it always goes with something like a case statement, or in this case a receive statement.
Yeah, right.
Part and parcel of the receive statement.
Yes. Actually, we have sort of seen that before, but it's not obvious. In the function definition where we did multiple matching, it looked very much like this, because it was the same idea. Assuming this, then this.
And we're spawning off this process to do this thing. Is that because you want to show us that spawn thing, or could we have just...
So the reason why I use spawn here is in part to show you that I'm starting a new process, and in part to show you that processes can communicate with each other, right? You can send a message from one process to another as long as you know some kind of reference to that process. Right. Yeah.
So if you just invoke velociraptors and child PID was defined, this would block?
If I just defined the function and...
If you didn't spawn it in a process and invoked it in the REPL,
yeah.
would that block?
So if I just called it in the REPL,
Yeah.
What it would do is send to the PID of the REPL a tuple with the PID of the REPL and that string.
Which wouldn't match anything in the receive pattern.
Right. It would depend what this is, right? If this happened to be like a date time, right, it wouldn't match.
So you have like conceivably two different computers running Elixir.
Conceivably, yes.
And they can send messages to each other.
Yes.
And if one of them is down and the other one is sending messages using the same first part of the tuple, the same identifier, this one comes up and it won't know about all the previous ones. It just gets the latest
Right.
piece of mail in the mail. Like every time a piece of mail is put in the mailbox, it replaces whatever was in there before.
Yes. Send is the definition of fire and forget.
Okay.
It's, yeah, implementation choices. Also, if that other computer comes back up, it will definitely have a new PID of some sort. So those messages won't work. You'll have to tell this one process to update, right?
You can't define the, it just generates the PID on its own.
Right, and so this entire idea of node discovery is fascinating. There's lots of solutions and ideas for it, and it's kind of a complex world. So we're going to just put it over here for now. It is also worth noting that, again, as indicated, this does not have to be multiple computers. It can be one computer, multiple processes. Distributed map. Woo! Yes, cause an exercise. It's not, yeah, I guess so. It's not an exercise. Sorry. You could build it yourself. Like you have all the tools you need. Well, I also learned that we're taking a break at 3 p.m. for half an hour. So like all the time that I thought I didn't have, I know for a fact I don't have it. So there's a book called Programming Elixir written by Dave Thomas. And he allowed me to use that bit of code, which is very nice of him. I only made one tiny change to it, which is inconsequential for the example. But he used a different function here, and I just used spawn because we saw spawn, and you don't need to know the other one. Raise your hand if you're brave enough to try and walk through this out loud. Other than the guy who works in Elixir full time.